All right. So our first thing we need to do on this is we need to figure out where the heck this angle is. And then we need to find our ordered pair for this angle. So first things first is what quadrant is negative pi over 6 in? Where's that going to be? It's not going to be in first. It's like I have question marks on all of those. What do we think? Remember, we always start here. This is our initial side. So if I'm going pi over 6 in the wrong direction, where are we going to wind up? Fourth. It's going to be this guy right about here. Because normally pi over 6 is this guy, right? Pi over 6, then we have our pi over 4 and our pi over 3. We're just going the wrong way. So this is our positive pi over 6. This is our negative pi over 6. Bless you. Bless you. So our negative pi over 6 is coterminal with what's the positive version of that angle? Because we're not used to seeing it as negatives if we think unit circle. It's 11 pi over 6. So those two things are the same angle. It's just whether we go this way or we go that way. So around this way gives us 11 pi over 6. Down this way is negative pi over 6. They're coterminal. So then let's think about our ordered pair for 11 pi over 6. What is our ordered pair for 11 pi over 6? Yeah, so it's going to be the 3, but don't forget our square root of 3 over 2 and our 1 over 2. Which one's negative? The negative 1/2, because this is down. When we work with our ordered pairs, and what this section is most working on is that our x's are our cosines and our y's are our sines. I always remember that being alphabetical order. X then y, cosine then sine. They're in alphabetical order. So our sine of negative pi over 6, which you can write it like this, that's totally fine, is which piece is sine again? Our negative 1/2. Our cosine of t, it's another way we can write it, means the same thing. What's our cosine? Square root of 3 over 2. Then how do we get our tangent of that angle? Yeah, sine over cosine. So we're going to take our negative 1/2 over our square root of 3 over 2. But that is horrific. So let's simplify this. The over 2's cancel out. So we can go with our negative 1 over square root of 3. But that's still icky. We need to rationalize it. Multiply it by square root of 3 over 3. And we get negative square root of 3 over 3. So we can use our ordered pairs to find our sine and cosine. Use our sine and cosine to find tangent. And we use all 3 of them to find our other 3. That gives us all 6 of our trig functions. Because our last bit is to finish it out and do our cosecant of t. What's our cosecant going to be? Negative 2. Because it's the reciprocal of sine. Dang it, I lost my gray. Then our secant. Yep, I'm going to do it in 2 steps just so we can see our 2 over square root of 3, which we would then need to rationalize to get our 2 square root of 3 over 3. And our cotangent of t. What's our cotangent going to be? Square root of 3 over negative 1, which is the same thing as negative square root of 3. So find our angle, find our ordered pair. Okay. So sometimes we'll be given negative angles, sometimes we'll be given big angles. So here's another one like this. We've got to find all 6 trig functions given that t is 25 pi over 6. So my question is, where is 25 pi over 6? Somewhere in the first quadrant. Why do we know it's in the first quadrant? Yeah, we're looking for some coterminal angles because ew. So let's see what's a smaller angle that's coterminal. So we would take away 2 pi. Or in this case, so we have that common denominator, 12 pi over 6. So 25 pi over 6, if I go backwards around the circle once, we're going to have 13 pi over 6 because we're taking away 12. Which means this is coterminal with what else? Pi over 6. Taking away 2 pi. So I'm subtracting 12 pi over 6. So 25 pi over 6. And we want to take away 2 pi. But I need common denominator. So instead of writing it as 2 pi, I'm going to put it as 12 pi over 6. It means the same thing, right?
Why are we taking away 2 pi and then changing it to 12 pi?
It's 12 pi over 6 to get to a common denominator. Because, there we go, 12 pi, 2 pi. I'm still just taking away 2 pi. But because 2 pi is not the same denominator, I have to put them in common denominator to be able to just subtract. So it's 12 pi over 6.
And that's how you got the 13?
That's how we got the 13. And we did it again.
Oh, and then you just took away 12.
And then I took away 12 pi again.
Okay, so
And
you're taking 2 pi away in the first place to find a coterminal?
Mm-hmm.
Okay.
Because if you think about 25 pi over 6, if I'm starting at that same initial side, we normally think of this is pi here and then 2 pi. So it's 6 pi over 6, 12 pi over 6, 18 pi over 6, 24 pi over 6, 25. So our 25 is just up our pi over 6. They're coterminal. So if you're given these obnoxiously big ones, find your coterminal. It's somebody on the unit circle. They're all going to be somebody that's on the unit circle. Keep going until you find one.
Until you find that you can't take away 2 pi anymore?
Mm-hmm. Or until you find something that you see on the unit circle.
Okay.
So our ordered pair for pi over 6 is what? Because we need that piece. Mm-hmm. Square root of 3 over 2 and 1/2. So what is our sine of 25 pi over 6, or sine of t?
1/2?
Mm-hmm. What is cosine of t? Square root of 3 over 2. Because our sine is our y, our cosine is our x. So our tangent of t is going to be what?
Square root of 3 over 3?
Mm-hmm. Yeah, because we do our sine over cosine, so we're going to have our 1/2 over our square root of 3 over 2. Our halves cancel out, so we're left with 1 over square root of 3, which we need to rationalize to be square root of 3 over 3. So yeah, totally fine. Square root of 3 over 3. Perfect. So let's find our coterminals, or our reciprocals. There we go. That's the word I was looking for. So our cosecant of t is 2. Our secant Yep, it's going to be our 2 square root of 3 over 3. Yeah. And then our cotangent, I'm just putting it over here because I'm running out of space. yeah, it's just going to be our square root of 3. If we take our reciprocal here, we get it the easiest. Okay, so sometimes we'll be given really big angles, sometimes we'll be given negative angles. You are always more than welcome to find a coterminal angle to be something that we are significantly more familiar with. Coterminal means they're going to have the same answers for stuff. Okay, we're going to look at a little bit more with our positive and negative angles here. I want to make sure I genuinely forget what time we're done on here. Cool. Okay. I'm going to go and get so I can actually see it, because I can't actually see it over here. So what we're going to do is we're going to look at the difference between those positive angles and those negative angles. So we just did positive pi over 6 and negative pi over 6. That was this guy. So these two pieces are really, really similar. It's just the angle was negative here and the angle is positive here. So some of these pieces are exactly the same. Some of these pieces are just off on signs. And there's actually a few little formulas that we're going to have to remember some things to help us remember. So we're going to look at when we have negative angles specifically. So these are based off of, graphs. We'll talk graphs another section. But we're going to have odd functions versus even functions. And our odd functions, we've talked about these before a little bit. Odd functions have origin symmetry. Bless you. Odd functions have origin symmetry. And what that means, and we can see it on the last one, is that when I have sine of a negative angle, what changes is the sign of the answer. So we have, that's going to be the exact same thing as if I had the opposite of sine of t. And if we look back at our pi over 6, when we had positive pi over 6, we had a sign of positive 1/2. And when we had our negative pi over 6, we had a sign of negative 1/2. Our sign changed signs. Our sign changed signs. So when we have odd functions, if we do in general, if I took my f of the negative angle, or f of minus x, we get minus f of x. That's going to be true for all functions that have origin symmetry. So since cosecant is related to sine, cosecant does the same thing. So cosecant of a negative angle is the same thing as the opposite of cosecant of that angle. Same thing happens with our tangents. And it happens, again, with our pi over 6 and our negative pi over 6. Tangent of a negative angle is going to be the same thing as negative tangent of the angle. And the same thing happens with cotangent. So on our odd functions that have this origin symmetry, it's that they are, the negative kind of hangs. So if we think again about when we looked at our positive pi over 6 versus our negative pi over 6, the only difference in our signs, remember signs are our y's, we had a positive y value here and we had a negative y value here. It was the same value, it's just one was positive, one was negative. Signs are our y's. Cosines, those are our x's. So evens, what's up? Evens, these have our y-axis symmetry, which we'll deal more with symmetry stuff when we get into the graphs, but I'm just putting it here so we see it. This is our y-axis symmetry. I'm not going to fit the word symmetry in there. There we go. Bless you. And what that is that our negatives really don't have much of an impact. So our f of minus x is going to be the exact same thing as f of x. So cosine, if we have a negative angle, cosine of minus t is going to be the exact same thing as cosine of t. Same thing with secant. And again, if you think about it in terms of our pi over 6 that we just did, our y's changed sign, but our x's didn't. Our x's stayed the same. We still had positive x's over here. This x was positive and this x was positive. So it's looking at our ordered pairs and saying what's changing and what isn't. So sines change their signs, cosines don't. And everything else is based off of that. So on some of these, we're going to give you angles, and you're going to be asked to find the exact value. So we're looking for a sine or a cosine, putting it through that. So this is our last kind of question we get really on here, I think. Might have one more that we do tomorrow. So we're going to have sine of negative 45 degrees. And the question will be worded like this. Find the exact value. I want to know sine of negative 45. Well, we just talked about how sine changes signs. So I could write sine of negative 45 degrees without doing anything else to it. I know this is going to be the exact same as the opposite of sine of positive 45 degrees. It's the same thing. They are going to do the exact same thing. That was not the eraser. I'm going to switch this to be an eraser. These two things, if my pens would stop being jerks, there we go, are going to be the exact same thing. So what we want to find is the sine of 45 degrees. 45 degrees is what in radians? Pi over 4. So what is our ordered pair for pi over 4 or for 45 degrees? Square root of 2 over 2, square root of 2 over 2. So this is one of those things we need to work on our unit circle. So, which piece is sine of our 45 degrees? Which is, what do we get the sine of 45 degrees?
For the fourth.
Mm-hmm.
Oh, the negative square root of 2 and the y value.
Yeah. So our sine is our y's, because cosine then sine. So we know that sine of 45 degrees is going to be that pink thing right there. So so the opposite of sine of 45, or sine of negative 45, I'm going to write it. So sine of negative 45 degrees is going to be the opposite of square root of 2 over 2. That guy. So we can take our positive angles and use it to find the negative angles, even if all we know is that first quadrant. So sines change signs. So when we had our negative 45, that means it's changed our y to be negative. So sines change signs. So if we have a negative angle here, I can find the sine of positive 45 and just make it be negative. So sines change signs, cosines don't. So secant is based off of which one? Yeah, secant, that's a reciprocal of cosine, right? 1 over cosine. So cosines don't change signs. That means we know that secant of negative 30 is going to be the exact same as secant of 30. So we need to think about 30 degrees. What is the ordered pair for 30 degrees? Square root of 3 over 2, comma 1 over 2. So which one's our cosine? The x value. So our square root of 3 over 2. So we know cosine of 30 degrees is square root of 3 over 2. How do I get secant of 30 degrees? Reciprocal. We flip it. So secant of negative 30 degrees is going to be the reciprocal of square root of 3 over 2. So we're going to have our 2 over square root of 3 which is going to be the same as 2 square root of 3 over 3, because you have to rationalize it. So cosines don't change signs, but sines do. Sines change signs. Okay. Questions on these two? Okay, so that gets us, I believe, to the end of 6.3. We are going to tomorrow do the quiz 1, just because I didn't want us to take, it would take literally every second of the class, the period time that we had today to do that quiz, and I didn't want us to have to rush that much. So you guys should be able to finish out homework 6.3. Remember that we're cutting a good portion of the ones listed because a lot of them were graphs, and I didn't want to do that right now. Ew. So these dates are all off now because yay for weather, so much fun. So we're going to do the unit circle quiz on Friday. We're going to do quiz 1 tomorrow. And at this point, we're still planning to get the unit exam in on the 7th. We will adjust as needed. We had a couple of buffer days in there for weather. I don't know if we've used them all up yet. I'll see, but it's just one of those. Weather's fun. Please remember to register for the IU class. If you were taking DC last semester, you do still need to register again. It has it listed as 2 separate courses. Yes, dear. Yes, it'll have something about trigonometry in the title. Trigonometric functions, I believe. Yeah. That's just sine, cosine, tangent. Those are the trigonometric functions. We can work with them a whole bunch.